So let's get into it. A bit about me.
Mm.
I'm I've been at Facebook for 7 years. Currently, I'm at a startup, but before this, I've been at Facebook 7 years. Overall, I have around 14 years of experience.
Mm.
Um, yeah, happy to learn a bit more about you, what you're looking for in this interview. If you have any interviews coming up, what kind of companies those are with and stuff, that'd be good to know.
Okay, great. So I've been in the industry for about 15 years. In
Okay.
my current position for about 3 years now, I work as a senior team lead at Atlassian,
Okay.
and I'm
Okay.
looking to transition to companies like Facebook and especially Google is my dream
Okay.
company. Yeah,
Okay.
that's basically what I'm hoping. One of those kinds of interviews is what I'm hoping what I would be able to eventually attempt once I'm done with everything.
Got it. Okay, so you want to try like a Google kind of interview?
Sure, yeah, if that's okay.
Okay, yeah, let's dive into it. Give me a couple of minutes. Let me just find a right problem that makes sense.
Yeah, no worries.
Um,
So I'm just changing the language to Python 3.
sure. Yeah. Um, I'll find something that's still trying to find something good. Um,
No worries. It doesn't have to be like a Google question. Like Facebook also works fine.
okay. I have a good Google question. I'm trying to find the definition from the code again. This is
Mhm.
actually I was asked this when I interviewed at Google.
Uh-huh.
Um,
Gotcha.
uh, Give me a couple of moments. Finding
Mhm.
something.
No worries.
Okay. All right. I think this is a good one. So I'm just going to post the question, and this is kind of copied from LeetCode. But
Okay.
again, this is a valid like googly question.
Mhm.
Um, I'll let you. Yeah, I'll give you some time to read through it, and then yeah, we can dive into it.
Okay. Okay. So the question is, there's a new alien language which uses the Latin alphabet. However, the order
Okay.
among the letters are unknown to you. So A, B, C, D, E is not the order; it's some other order.
Mm-hmm.
You receive a list of words from the dictionary where words are sorted lexicographically by the rules of this new language. Derive the order of the letters in this language. Order of the
Yep.
letters in this. Okay, gotcha. And lexicographically means like in the new dictionary. I mean,
Mm-hmm.
lexicographically by the rules of the new language. Okay, gotcha. Okay,
Mm-hmm.
so we're looking at the example.
So you see this. Yes, if you just look at this word WRT, the
Mhm.
fact that this is a word means that W comes before R and R comes before T in the alien language.
W comes before T.
R. W comes
Oh,
before R, and R
uh-huh.
comes before T.
Oh, okay, okay, I see. So I was trying to work my way through this example. So T and F, this means that T comes before F. Um, W comes before E. W comes before R. Okay, gotcha. I see what you were saying. Okay, cool. So let me see if I could maybe think of some um, brute force approaches to this. So the idea is we need to find out which word comes before what, and the way to do that might be to compare adjacent words. And if they're Before that, let me just get a few questions out of the way.
Mm-hmm.
Can there be duplicates in this list? Can there be duplicate words?
No, let's assume that there are no duplicate words. Again, the list is sorted, so if there are duplicates, you can eliminate them easily. But let's assume there are no duplicate words.
Okay. No dupes. And the second thing that I wanted to ask is just to get an idea of the constraints, like how many words can typically appear in this input list? In this dictionary?
It could. I don't have a good. There's no good assumption, so we can come with whatever assumption makes sense. It
Okay.
could be n, like, yeah.
Okay, gotcha. Okay, n words in the dictionary. Okay, and the constraints of this, each individual words also, like I think maybe we can define it as length m.
Mm-hmm.
And any constraints that we have on that, like how long m can get to, like any length, I suppose.
It can get to any length, yeah.
Okay. So
it can. I guess it can be up to 26 characters, right? Because that's the length of the interview. Or sorry, that's the length of the string or the alphabet.
Okay, yeah, 26 characters is the length of the alphabet. But I was talking about the words in the dictionary. Can they get to more than? I'm assuming like it's okay to repeat some letters, like T, T, E here.
Yep.
Okay.
Yep. Yes.
Okay. 26 characters in the language alphabet.
Yep.
Okay, got it. Okay. So what's a good way to approach it? Let me maybe take this example and play with it a bit more to get some ideas. And I'll be looking to see if I can come up with a brute force first. If there is a brute force, if not, I'll try to see if I can come up with an optimal algorithm right away. But let's see. Brute force makes more sense to me. I'm just going to put them all in one line so it's easier to see. Okay, so let's say that this is the input of the dictionary, and how would I basically know? I know that these are sorted, so that's one thing to keep in mind. And so how would I know if one letter comes before another? So I can compare adjacent words and check to see what's different. What is the first letter that is different? So I was thinking for I, this basically we'll have to do this for all combinations in order to be able to figure it out. So for I and for J, basically compare words of I and J, words of I and words of J, to see first letter that is different. And we need to basically indicate that that letter is actually of a lesser value. So maybe what we can do is assign values. So we can maybe use assign values. So maybe we can do something like the ord of the actual letter itself, or actually come up with like our own ordering for that, like some way to assign values. It's not clear to me like how I would do this yet. Yeah, but this algorithm would basically mean like we compare every word against the other, and so it would be at least an O of n square algorithm. So this would be O of n square algorithm without taking into consideration the complexity here. The complexity here would be comparing words of length m, so that would be at least an O of m comparison. And then to figure out if there's some way we can keep them in sorted order and sorted by our own formula, that might be a constant operation. But depending on how we come up with this assigned values, it's all very vague now, but this is basically order of m, this is order of n, and this is also order of n. So seems like an O of n square m algorithm that we have so far, and we should probably try to do better than that, right?
Yep.
Okay.
Well, let's not worry about the time complexity for now. We can see if we can come back and do better there. Yeah, let's.
Wait,
is there anything else you need to do?
Sorry? Say that again?
So you say compare words I and J to see first letter that's different, and you find the values. How do you store this stuff? Like, do you need storage?
Yeah. How do you store it in sorted order, right?
Yep.
Or okay, so like for example, is this the output that our function is expecting? Like it's a string
It's the correct
of these.
order. Yes.
Okay. So then we need to keep a sorted data structure of some kind, and then eventually get the output. So if there are values, numeric values that I could assign, and I could keep like a sorted data structure, then at the end I could maybe get the elements out of that sorted data structure. And so keep sorted data structure, insert into sorted data structure by value, by constructed by assigned value, and then basically at the end we would visit all elements, or basically get increasing order of elements from data structure and construct a string. So for example, if I were to keep them in like a heap data structure or something, then I would just continue popping from the heap and constructing an output for that. Now that means that I'm adding extra complexity here. So inserting into a heap will take all of log of n time. Oh, sorry, you told me not to worry about that time complexity. Never mind. But I just wanted to call out that it's because we'll have to now maintain something in sorted order.
Yep. Okay. That sounds good to me. If this looks good, we can begin implementation.
Okay. I still haven't figured out exactly how to assign values for these.
Okay.
And should I also try to look for a more optimal approach than this?
Let's not worry about the optimal approach. I want an approach that works, and then we can worry about optimization later.
Oh, okay, gotcha. All right. Okay. So, so how do I keep this in sorted order? So I haven't actually decided that what values go into this, and this might actually change the algorithm a little bit. So before I write code, I'd like to make sure that I figure this part out. That is, if the first letter is different, then assign values. So this is basically just going through both words one letter at a time. When you find the first letter that's different, then Betterify is Wordify at that point will basically have a letter that should precede the second one. But how do I know what its absolute position is? I still don't know that yet. So it's possible that this approach won't work. To give you an example, let's say I compared WRF and ER, and I found that W is actually less than E. Like W should go before E. Then I still don't know what E's position is relative to, say, R. Right? I would maybe only know that if I continued through the list and found a direct correlation between E and R. I don't know what its relative position is between W. Like if there were letters in between W and E, I don't know exactly where this E would go unless I actually did the comparison to the previous elements. So I don't know how we would assign a value like that, absolutely. So let me think about that for a second.
Okay.
Do you see what I'm saying though? Like,
yep. So like, how do you maintain the relationship?
Yeah, exactly. Yeah. So I need to maintain the relationship somehow. So one way that I can think of doing that is to usually relationships to me signify a graph kind of approach. Like if I could maintain this somehow in a graph data structure, that would actually help me. So let me see if that would actually help me. Let's say that I found out that W goes before, I mean, from the first two comparisons, I would only figure out that T goes before F. So what if I stored it like that? Would that help me? T goes before F, and then from the next two letters, which is WRF and ER, well, actually my algorithm compares the first word to every other word. I know that W goes before E, so W goes before E, and then after that, from this I still only learned that, and from here I learned that W goes before R as well. Oh, something's wrong. Okay, yeah, W goes before R. Now, in the second iteration, I compare WRF to everything else. Again, nothing to get from here because the search will stop as soon as I figure out the first word, which is different. So the interesting case comes when we compare ER and ETT. From there, I figure out that R comes before T. Yeah, R comes before T. And then when I compare ER and ERRFT, I only learn that E comes before R. That's all I can learn from just using the word ER. And now ETT, from there also I can only learn that E comes before R. So with one pass of this double for loop, if I was able to construct this structure, maybe what I can do is figure out the order from this structure somehow. Does that make sense?
Yep.
Okay. So I compared W to everything else, and this is all I learned. E and R. Okay, yeah. So okay. So how do I know what comes before what? Maybe what I could do is I have ideas of maybe trying to do like a topological sort of this graph structure.
What is that?
And the idea of topological sort is if I built this graph, then the elements that comes before, like if I have that order, the elements that come absolutely before, like it's basically building a directed graph from W to E and W to R. So in the final order, W will come before E and before R. Now the order of E and R will have to be determined by E and R. And I'm realizing I missed a clarifying question. Is it possible to completely deduce the order of all the letters in the words given the input?
Yes. Let's assume this.
Okay. Okay. So I think if I did a topological sort here, which is the idea of that is I basically I start at one point and then basically start with any point here and visit all its children. And once there are no more children to visit, then add that element to the output. And then go back to the parent. And then once the parent has finished visiting all its children, only then add that to the output. And then if I reverse that list, I would get the topological order. So in this example, if I started at W, I would visit E and R, and then I visit E, I would go to R again. I mean, I would be first visiting R. So I just need, I guess I'll need a visited set also to keep track of what's been visited so far. So far W, E, and R will be in the visited set. Once I come to R, I see T, so I'll be visiting T. And then I find out that T has one child, which is F. So I'll be adding T and F here. And then from F, there's nowhere else to go. So from here, I would be constructing my output set. My output set would first contain F. Then I'd go to T, and I'll write T, and then R, and then E, and then W. And W won't be, I mean, I'll be writing W because there's no point visiting another child because that child has already been visited. It's in the visited set. So theoretically, if I reverse this, I should be able to get the topological order, which is W, E, R, T, F, which at least in this example seems to be the right answer.
Yep.
Okay, so then my algorithm basically now is compare each words and make a graph or add to a graph. The graph is going to contain, the part of the graph is letter to succeeding letters, or successor, how do you call them? Like letter that comes after successor, right? Successor letters. So add to graph, first letter that's different. So okay, so maybe what I can do is I can get started on the code just because I've taken so long. I'll just start off on the code and then try to figure out these details.
Okay. Yep.
Okay. Get order of alien alphabet. And we're going to get a dictionary. Oh, dictionary, yeah, okay, dictionary of words. And this dictionary is basically a list. So I'll just call it like sorted list of words. And okay, so the first thing to do is iterate through this dictionary, and then something that I have to think about. Do I have to compare every single word, or can I just do adjacent words? Okay, I'll maybe optimize that after I do the algorithm once correctly. Like my thought here is probably there's no need to run this loop twice if it is guaranteed that this will always be smaller than this. Then it's enough to check this and this, right? Like I don't think I learned anything new about WRT by checking it with ER directly that I won't from WRF. But I could be wrong about that. I'll check that assumption at the end, if that's all right.
Okay.
Okay, so let's just call it a graph. It's basically going to be like a dictionary, and then for I in range, len of let's just call that n actually, len of sorted list of words. In range n, and for j needs to start from 1 past I, so I plus 1 to n. And now I need to compare the two strings letter by letter. So I have a question here. Okay, so let's say that I have ABC in the input, like I'm on line 44, or I can just write it here too, like just above the code. If I have the word ABC and ABCD, right, can this be possible in the input? Because it's still sorted. Right?
Yes. Yeah. Let's assume it's. Well, I mean, I don't think you learn much, right? You just like what do you learn from there?
Yeah, you don't learn anything from there. Okay, so it's enough to compare just the first M characters, right? Okay, yeah, that makes sense. So what I need to do is compare two characters. Let me just comment this out. Oh, that's cool. Okay. So, okay, I have two strings, words of ij. First is equal to words of I, and second is words of j. Now I need to compare both of these character by character. So I could probably just zip and compare letter by letter. So for, say, first character and second character from in zip of first and second, I need to look up the Python definition for zip once again, whether it'll actually work with sorted list of words. I'm just going to write the two words first, and I'll refactor this for sure. So, yeah, this should compare, like this hopefully won't throw an exception. This should just take like as many characters as there are available. And the first time, if the first character not equal to second character, that's when we need to add graph of first character dot append to second character. And so then it becomes a good idea to make our graph a default dictionary. Default dictionary, and then import that. Default dictionary that will have a list. So it'll always be initialized, and we don't have to worry about first time appearance of first character or something. And so if this is the case, then we can break away and then move on to the next word, next two words. If not, we learn nothing and then we don't insert anything into the graph. So this should produce the graph. Let me see if I'm missing anything at all. Find range J for J in range 1. That's words of find, words of J. Yeah, okay. First character, second character, and this zipped. Yeah, okay. So this is constructing the graph. Now the idea is we need to try and get a topological sort done. So let's write a helper function for getting the topological sort. And that takes in the character. And we need to find the adjacent characters. So two questions here is, how do we, like, it is possible for us to get the ordering always. So, okay, so then I can begin in theory with any random character. So let me actually write the topological sort, and then I can figure out how best to go about initializing the search for a topological sort. I mean, starting off the topological sort. So I need a visited set. And I need output list, which is basically output, which is a list. And the idea is once I call helper, I'll be writing to the output in reverse order. So the first thing to do is add this character to visited. Second thing to do is for successor char in the graph of that character. For each successor character in the graph of just that character, we need to visit successor character if it's not already visited. So if successor character not in visited, then we visit successor character. And then finally, we add the character to the output list. And then at the end, after we call helper, and I don't know how I'll start this, maybe I can just start with any random letter. It should, no, if I start with any random letter, it won't actually know where to, which to compare. So it would help if I had a list of all the letters, A through Z, and then start a topological sort with all of them. So we can actually limit it to the input as well. But the idea is we need to return, so once we start this, then we need to return the reverse of the output. And the reverse of the output in string format is what our request now is for. So this would be what we would return. I haven't figured out how to start this. One option is to start it for every letter. So for a letter in A, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. If letter not in visited, then start the topological sort from that letter, and and then just continue. But yeah, I'm not sure. Like if we only had like a few letters, then this would be overkill. Like we would be going through letters.
Yeah, how do we do it?
Yeah.
I mean, it's fixed cost, right? Like it's again the length 26. But the thing is, the alphabet could be longer than that too. You know, so since you're using Latin alphabet, it's 26 letters. But theoretically, it could be longer than that.
Right.
Looking at the graph itself. Yeah. How do you know?
The letters, right? The input letters. We can try to use the graph's keys. So, for example, when I drew this graph here, let me just copy and paste it right above the question. If it's guaranteed that there are relationships between every element, and it's possible to guess the output, we should be able to start with any one of these, W, R, T, and E. So maybe we construct the graph first, like this, and then after that, just use the graph's keys for getting each letter. Since the order does not matter, right? So if that's the case, then we should be able to determine the order. What I can do is I can Is it okay if I run through this example with whatever code that I've written?
Yep, let's do it.
Okay. So let's say my algorithm says, let me just reduce the font size. Okay. Can you still see?
Yeah, I mean, I can.
Okay.
Sorry, where? Oh, yeah, I see. Yeah, I see now.
Yeah, I'm in line 59. Yeah. Okay, let me just make my window full screen and then I can run through this. Okay, so what do I do first? I first create a graph G, and then let me see if my algorithm actually does what it says it'll do. So first we are comparing, and the input list, I'm just going to copy and paste that too real quick. So this is the sorted list, words. And I'm going to start at index 0, 1, 2, 3, 4. Okay, so my I is here. It starts at 0. J would start at I plus 1. And then I would compare, I would do a zip of both of these. So that would be WRT and WRF. And then I would take first character, second character in WRT and WRF, compare them, and then I'd find out that T is different. So then I would write T, comma, F into the graph. Then I would expand and move J to E. And from here, I would zip both of them. It'll have WR and ER if I understand how zip works correctly. And then I would compare them character by character, and I would get W and E. Then J moves again to I plus 1. So we compare W and E again, and then, oh, okay, here's a problem. A problem is we could end up with duplicate comparisons. So I could have duplicate characters in my output value, and one way to avoid that is to make it a default dictionary of a set. But so for example, when I compare WRT and WER versus WRT and WETT, I would just be appending to a list, which means it'll be too easier. So instead of that, I'll just use a set, which should solve that problem. So when J is here, it solves that, and then we compare W and R, and then I drag R here. Okay, and now I moves to this. J moves to E. Again, it's the same thing, like because we're using a set, these values will be overwritten. I mean, it won't be written into the set. Now is an interesting thing, I and J. You compare I and J, and then compare character by character, R and T. And the first character is not equal to second character, so we append. Oh, now we cannot append, we have to add. And we add R to T now, this relationship. And then J moves to 4. I have made sure that it's I plus 1, right? Yes. Okay, J moves to 4, and we compare E and R this time, and fails there. And so I break out of that loop. Okay, so then finally we use I and J, we find E and R relationship, fails there. And then finally we come to I, and there's nothing for this to compare, so the second loop won't run, and we exit the loop, and we get the graph structure. So this should work, this part should work. Now the topological sort part, I could start with T, because I'm checking to see for letter in graph.keys. So I could start my journey with T, but that shouldn't matter because we're still getting it in topological order. But let me confirm that. So I start with T, and then from T, I add it to the visited. My output still doesn't have anything. And from T, I go to F, add that to visited. From F, I go to nothing. So basically, F gets added to the output. And T doesn't have another child, so that also gets added to the output. Now in the next iteration, I run W. And for W, I first add it to the visited, and then I check to see each of its children. Are they visited? For successor character, if not in visited. Okay. Helper of that success character. Okay, yeah, I think that part might work. So for W, sorry, I was at W now. and the first thing that I'll visit is E, and for E, the first thing that I can visit is R. So on the way here, I would be adding W, E, and R. And then from R, there's nowhere else to go. So, oh wait, from R I can go to T, but T is already in visited. So I add R there. Yeah, T is in visited, so I add R there. And then, and then I come to E, and from E, yeah, E has no more children, so I just add E, and then finally add W. Is this the right order, though? W-E-R-T-F. W-E-R-T-F. Yeah, okay, so the opposite is reversed. That is the right order. Okay, so should I try to run this and write some test cases or something?
Yeah, let's run it.
Okay. So for test one, maybe we can just run it with the example that you did provide me, so that
yeah, let's do that.
Yeah. Test one, normal case, and let's say word is this. Oh. And output is get the Boolean alphabet of words, and we want to print the output. Okay, let's see if, let me bring that through. Graph.keys dictionary changed in size. During iteration. I'm not mutating a dictionary, so it shouldn't actually change in size. Oh, by the way, on the code visited. Oh, okay, I see. The character was not there in graph. Okay, so maybe what I can do is just make a copy of the keys. So, letters is basically graph.keys, and I think it's called copy. Or I can just say list of keys. So WRTF, I think, is the right WRTF. Yes. Okay. So now maybe we can test some edge cases.
Okay.
Just not crash. So this time word is empty, and then I'll just copy and paste this. Oh, I didn't. I need to comment this out, I think.
Okay.
Yeah,
I mean, I think you printed an empty output.
Okay. Okay. Cool. Then the next one is test. Just one word in here. Is words, and in this case, like all we can expect to get is W. So I think that should be the output. Let's see. Yeah, we're not getting that. And let's see what the reason is. The reason is I've always started it from I+1. So I won't be able to get the range based on that. So maybe what I can do is I can handle that case separately. So for example, if the length of this, if len of words equal to 1, just return words of 0 in a list format. I don't think I can modify my algorithm to just ensure like the next words, because there's literally nothing to compare. Which
that's fine. Yeah, I think can you give me an example of this scenario where, like take W, like take words and output, and what I want to see is um, uh, an incomplete set. So I want to. Can you provide a set of words with which you're not able to get the order, and what the output would be then? So what if you remove WRF from the set? What happens then?
What if I removed? Oh, okay, okay, I see.
WRF from the set.
Okay, I see. So basically, we want to test the case where it's not possible to infer an order, right?
Yeah.
So if WRF was not there, then how would we ever determine the relationship between W and F, for example, right? Yeah,
Yep.
so in this case, yeah, we wouldn't be able to determine that. The only way I could have done that is if there was some other word that contained W, which would force a comparison to F,
Hmm.
which I don't
Like,
know
I
if.
guess my question is then, if you're not able to determine the order, I want to throw an exception saying you're not able to determine the order of all
Ah,
the file of the alphabet.
okay, okay, okay. That makes sense. So what I could do then is, we know that output figures out some order. So if len of output not equal to len of, or is actually less than length of letters. Oh wait, letters is whatever we do have a relationship for in the graph. So I would actually need
Hmm.
to figure out all the letters in the input itself, and all the unique
Hmm.
letters in input. Okay, so
Hmm.
let me handle that case as well. So let's assume that all input letters was something that was there. Then I would need to raise an exception saying unable to infer order among alien letters, and then just return from it. I mean, if I'm raising an exception, it'll return. So all input letters needs to be constructed with just by going through every word, and then so one thing that I can do is first join all the words. So join all the words into one giant letter, and then create a set out of that. So this is all unique letters. So this should actually take every word, join it into a string, and then make a set of all the unique characters. So yeah, so yeah, now we're raising an exception. Is this what you were looking for?
Yep. Yes.
Okay, I see. So the input actually does
Cool.
give us the can actually put us in a state where it's unable to actually complete, right? It's unable to actually figure out all
Yep.
the letters. Okay, got it. Okay. Okay, okay. I should maybe have clarified that. Yeah, makes sense.
That's right.
Should
Uh,
try to do,
uh,
yeah,
no, I think
sorry.
we can move to the feedback. We can move to the feedback part.
Sure. Yeah.
So I think, yeah, overall, positive feedback. I think what, let's see. So I think it was good that you verbally explained your approach.
Mm-hmm.
You talked, I mean, I think you talked about the constraints, um, in the language alphabet, no dupes, N words in the dictionary. I think that's all great. Um, you I think you started with an initial approach, and then you worried a bit. You proactively talked about time complexity, which is good. And then you
Mm-hmm.
also talked about how you need to use topological sort. Um,
Mm-hmm.
that's that's good as well. So yeah, let me write down these notes. I'll just put these as notes. So I think positive is writing down as much pseudocode as possible, which I think you did. Beginning pseudocode as possible around your approach. Um, I think another positive is for communication. In general, I think your communication was crisp and clear throughout. And it was always clear what we were trying to do, and you were verbalizing as you were talking. Sorry, verbalizing as you were coding.
Mhm.
So I think that's great. Another plus is, you concluded that topological sort is the way to go, and also you also concluded that is the way to go. Sorry, is the way to go. What? Okay. Yeah, I think you also concluded that you graph structure to maintain relationships. I think that was good. And then what's the final thing? I think you proactively tested test cases. So I think all in all, I couldn't really find any flaw in your approach. I think the one, like, maybe like question mark I would have is, and well, not really a question mark. I think you came up with I think you proactively talked about time complexity. I think that's a good plus, but proactively talked about time complexity. I think at Facebook, they would want you to, or generally at many companies, they would want you to implement stuff and worry about time complexity later. Like, can you optimize later? Google wants to come up with the best time complexity solution. So that it really depends on the company you're interviewing at and stuff. So I don't think
Right.
there's any wrong approach here, but yeah.
I see. So Facebook wants code first and then optimization, right?
Exactly. Yeah.
Oh, okay, I see.
Yes.
Oh, got it. I've also heard that Facebook tends to ask like not one but two questions. Is that right?
Yeah. So Facebook asks you an easy question. So think of like an easy question as like, given two strings, calculate the output. So like lead code easy,
Mm-hmm.
and then one lead code medium. Whereas like Google starts with the lead code medium and then it can be a lead code medium hard. So like medium but approaching hard mode. I think that's kind of what Google likes to go with, and Facebook goes normally with like easy one and then a medium one. And if you solve the easy one, you need to solve it within 20 minutes so that you get the opportunity to work on the medium one.
Okay, okay. Solve it in how many minutes?
I would recommend solving the easy problem that the Facebook asks
Uh-huh.
within 15 minutes.
Within 15 minutes. Okay, gotcha. And so that there's 45 minutes for the. Is it 45 minutes the interview or is it 1 hour?
It's 45 minutes.
Oh, it's 45 minutes. Okay, gotcha. Okay, okay, got it. So then I'll have 30 minutes to maybe work on the harder problem, right? Okay, got it.
Yes, exactly.
Okay, understood.
So you want
I
to
was,
like pace. Yeah.
yeah, I'm sorry. Go ahead, please. I cut you off.
No, I'm saying you want to pace your interview so that you have the 30 minutes to do that.
Oh. Okay, got it. Yeah, yeah, understood. Okay. And are the questions asked usually this complex or like this one? Is it a hard problem or is
Google's
it?
is, I think this is medium, or could be medium hard. I don't know off the top of my head. But Google
Uh-huh.
loves to ask these kind of questions, and they'd rather ask like one question that requires a lot of like thinking and maybe some
Uh-huh.
code. But they always like prefer to stick to like one problem.
Oh, okay. Got it. Okay. Okay. Understood. Okay. Cool. Cool. And any advice for me, like in preparations for these? So just maybe. So assuming you don't have to run away, do you have like 5 minutes?
I do have 5 minutes. Yeah. I don't
Okay.
really have any. So go ahead. I mean,
Sorry.
I think in terms of like, I
Mm-hmm.
mean, I don't really have any like specific advice for these companies. I'd say for Google, they want to optimize more for algorithms, and they want to ask you algorithmically tough questions. So you want to think about preparing for like graphs,
Mm-hmm.
dynamic programming,
Mm-hmm.
sorting. So things that are generally considered algorithmically tougher. Whereas Facebook will ask you slightly easier questions, but they care about how quickly you're able to write the code for a problem. So they'll ask you things like string manipulation or like arithmetic problems or like data structures, simpler data structures, but they expect you to solve the problem faster.
Okay, gotcha. Okay, understood. Okay, thank you so much. And if you could what was your journey like for this? Like, did you get both offers, or did you stop at Facebook, or what was that like?
Well, I stopped at Facebook. Google I interviewed when this was like about, I want to say 13, 14 years ago. Facebook I interviewed about around 10 years ago.
Oh,
Google I didn't really, I was able to solve this problem, but I didn't really get through to the offer point. But Facebook, I was able to get the offer, and then kind of
I
go from
see.
there.
I see. And did any mode of practice help you? Like, were you practicing by patterns, or were you practicing random questions when you were preparing?
I was practicing like random questions really to make sure I got the entire like set of questions answered.
Oh, okay, gotcha. Okay, awesome. Thank you so much for your help. Really appreciate it.
Well, yeah. No, likewise. Thanks a lot, and yeah, best of luck for the interviews. Again, I think you're doing just fine. Your communication is strong, strong problem solving ability and stuff. So yeah, I don't really see any much issues there. Yeah.
Gotcha. All right. Thank you very much, and have a good night.